Alright, Jeff. We're just putting together a quick little video for you here to see this unit working. We're right now on the ×1 scale, and I'm setting about mid-band right now, so we're putting out about 10.5 hertz according to frequency meter up here, and we see a nice sinusoidal waveform on the scope. We have adjustable amplitude, plenty of it, and as I have a choice, I'm going to go ahead and change my band range here. Right now I should be reading about 1 hertz, which it's just dang difficult for everything to display, but you can see the sinusoid being drawn there. And we're running about 1.5 hertz right now. I could cut this down on the dial and bring her in closer, but takes a moment for that to react. So as you can see, we got about 1.2 hertz up here. We're getting our sinusoidal graph on the oscilloscope, and then I'll start to rotate, take us to the other end of the range. Alright, we should be, I don't know, somewhere around 10 hertz up in here. We see that definitely have picked up a sinusoidal trace. We're at 10.6 hertz right now, and I'm at about 10 on the scale. So if I go times 10, there we go, 103 hertz. There we go to times 100. 10 times 100 would be 1,000. And right now we're setting at about 1,024. Nice sinusoid. Here we go to 10,000. Still a nice sinusoid. And we're running at about 10.2K, 10.3K. Times 10 times 10,000, we're at 100,000 now. Okay. Alright. We're running 102.8K. Okay, here we go, 10 times 100,000, this should be 1,000,000. Still got a nice clean sinusoid. We're running 1.022 megahertz, 1,022 kilohertz. And then finally we go to the times 1 meg range. 10 times 1 meg, should be 10 million. Still got a nice clean looking trace. And we are running at 10.08 million hertz. So if you rotate this center dial here, right now I'm in the ×1 position. I could go to the left, that'd be ×1/10. If I go to the right, it's ×2. tells you on the scale up here, 0.1 times 1 times 2. So right now I should be reading just about 20 million hertz at this point, and we are running 19.9, and our trace is just beginning to show a little distortion. Not bad, but it's there. But this is at the extreme of its range. So we've covered everything from 1 hertz up to 20 megahertz, and you've seen it. We have what they call the variable offset, where we can adjust the position of the waveform relative to a DC line. So if I put this onto DC, and then if I change this dial now, where I say put the trace above the DC line, that's exactly what it did. It raised it up above the DC line, and it's up on the top of the screen now. And there we go. So it raised up to this point of the screen. If I bring it back to where it was, then you'll see that it's centered on the screen. Okay, and I can go below the line too. Alright, and we got a variable symmetry. Let's see. Different waveforms. We're right now we're setting on the sinusoidal waveform right now, and I can go to the triangle. That's the square wave. This frequency, it doesn't do a square wave all that great. It's a little better. Has something to do with the probes here too. And triangle, sinusoid. I'm adjusting the intensity right now. Okay. So you've seen the thing in operation. That's what it does. It's a much better generator than you'd get for similar amounts of money. For $100, you get the little Heathkit tube RF generator, and that's all it does. It just generates RF, and it doesn't even do that very well. So this is it.